So is the following redox reaction? Guys, at this point, please pause and really try to do this on your own, just because it's good practice. It's how you're going to know. So let's go ahead and do this. I know my elements in their native state are 0. So I really only have to solve for these compounds right here. Silver nitrate, copper nitrate. So I'm going to go ahead with atom, number, oxidation state, and total. Ag. You can do NO3 separately, where you have nitrogen and oxygen. Because it's going to be an ion, I know that these have to add up to be -1. So there's 1 and 1. These have to add up to be -1. So to add up to be 0, this has to be a +1, +1. And nitrates on both sides, it can't go through a change. If we were to do the same thing with copper nitrate, here we've got copper, there's 2, I'm sorry, no there's not, there's 1 copper, 2 nitrates. Each one of the nitrates has to have oxidation states that add up to be -1. 2 times -1 is -2. Means this has to be +2 and +2. So +2, nitrate is still going to be -1. So here we have copper going from 0 to +2, and silver from +1 to 0. So if we look at this, this is definitely a redox reaction because we have changes in oxidation state here. Now, I like to start with what's being reduced. Silver is reduced, which means that the silver nitrate, reactant containing silver, is our oxidizing agent. Copper is being oxidized. It's going from 2 up to +2, which means copper solid, the reactant containing copper, is our reducing agent. Okay? So now going through this, guys, if I were to look, element, compound, compound, element, this is a single replacement reaction, or single displacement, either way. It is not gas evolving, I don't see a gas. It's not acid-base because I don't see an acid or a base. It's not precipitation because it's not a compound that's falling out, but it is redox. So to fully characterize this, it's a single replacement reaction that is also a redox reaction. Same thing here. Just good practice. Go ahead and hit pause and try this on your own. I'm going to assume you have done that. And elements in their native state are 0. Hydrogen in a compound is +1. Oxygen in a compound is -2. Magnesium, oxygen, hydrogen, 1, 2, 2, -2, +1, gives us a total of 2 plus 2. 2 times -2 is -4, so this has to be +2 and +2, which makes sense because magnesium should form an ion with a +2 charge. Okay, so for space reasons, I'm only going to write what's changing. We have magnesium going from 0 to +2, and hydrogen going from here to +1 all the way to 0 on this side. Now I know some of it is +1, but it doesn't matter. We're only looking at what's changing. So here, this is a redox reaction. It is also a gas evolving because there's hydrogen. See that gas right here? I don't see a precipitation. I don't see an acid, even though I see a base over here. I don't see acid and a base. So let's look at this. This is an element, compound, compound and element. So again, this is a single replacement reaction. So that's fully characterizing. Now here, magnesium is going from 0 to +2. Hydrogen is +1 down to 0. So hydrogen, the element, is reduced. What I am touching to make that happen. So water, the element containing, the reactant containing hydrogen, is our oxidizing agent. Magnesium is being oxidized. So magnesium solid, the reactant containing magnesium, is our reducing agent. Alright, silver nitrate reacting with sodium chloride to produce silver chloride and sodium nitrate. These are the same. Here, this has to add up to be -1, so this has to be +1. This has to be add up to be -1, so this is +1. In a compound, this is going to be +1, -1, -1, +1. So if you make your tables, that's fine, but I'm assuming you do that and you can see, oh, silver is +1, nitrate didn't change, sodium didn't change. This is not redox. It is a double replacement reaction. Compound, 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 compound. And even though we haven't talked about it, it is a precipitation reaction. So that'll be in the next video. Okay, so the last thing I need to talk to you about with redox reactions is balancing them. Now, this seems kind of interesting, but it's kind of fun to do, especially when you are dealing with things like batteries, and it's really not as bad as what it sounds like. So for these, we're going to write the half reactions, meaning we're going to write the reactant and product that has the same element. Then we are going to balance everything except oxygen and hydrogen. If the oxygen atoms aren't balanced, we're going to add water to balance oxygen. We're going to add H+ to the side that needs hydrogen. We're going to balance our charges by adding electrons to the more positive side. And we're going to multiply to make sure that the same number of reactions are, the same number of electrons are being used. You can't have 2 being gained but 4 lost. You have to have the same number or it violates the law of conservation of matter. And then you're going to add the equations and cancel out anything that's the same on both sides. So let's try one. Here we've got dichromate and nitrite going to chromium-3 and nitrogen. So to write the half reactions, I kind of look for the things that have the same elements, okay? So I'm going to now rewrite those. I like to line these up. So I'm going to do dichromate going to Cr3+, and then down here I'm going to do nitrite. Notice the charges have to be here, guys. Going to nitrate. Okay, so let's first balance the elements other than oxygen and hydrogen. Chromium I have 2. I need to have 2, so I'm going to add a 2. Nitrogen I have 1 and 1, so I'm okay there. Now guys, I would still make my table. I just don't have room for that, where I would say Cr and O and that kind of thing. Actually, maybe I can. We'll do it like that. And so we have 2, now we have 2, 7, and none of those yet. Nitrite going to nitrate. Here we have nitrogen and oxygen, 1 and 1, 2 and 3. So now we need to balance those oxygens. And the way we're going to do that is we're going to add water. So I have 7 over here, so I'm going to add 7 waters over here. 2 and 3, so now I have 14 over here. 2 and 3, I need to add a water over here, so that now I have 3. In terms of hydrogen, now I have 2 there, so we'll deal with that. Okay, so after oxygen, we need to add H plus until we have equal hydrogens. 14 hydrogens on this side, so I'm going to add 14 H pluses over here. Down here I have 2, so I'm going to add 2 H pluses over here. Now we need to look at the charges. This is probably the hardest part of all of this. Here I've got 2 chromium 3s, 2 times plus 3 gives us plus 6. Here I've got plus 14, 14 times 1 is 14, and then a minus 2. So I have plus 12 overall. Plus 12 plus 6, that's not gonna work. We need to have these be equal. So we're gonna add 6 electrons here. Minus 6 gives plus 6. Plus 6 is now gonna be equal on both sides. You wanna have the same charge on both sides, otherwise you have created or reduced something that it's just not possible. Now in terms of down here, I have a nitrite with a minus 1. Over here I have a nitrate with minus 1 and 2 pluses, so plus 1. Minus 1 plus 2 gives plus 1. So same thing, minus 1 plus 1. It's not going to work. To make these equal, I'm going to add 2 negatives, so 2 electrons. Minus 2 gives us minus 1. So now minus 1 charges are on both sides. So we have an equal charge distribution, which is really good. So yay, yes. Okay. So let's look at these. At this point, if I were on a new piece of paper, I would actually write a line and continue. Because of how this is written, it's kind of hard to do that. I'm going to go ahead and do some erasing and just move things closer together. But I want to show you why first. So up here I have electrons, and down here I have electrons. But I have 3, I have 6, and I have 2. I can't gain 6 electrons if something only gave up 2. That's not how it works. I mean, I'd really like to gain $1,000 when, you know, I don't know, I get paid from somebody 100. It's not how it works. It has to be equal. And so we need to multiply this to make sure that those 2 reactions are the same. And so I'm actually going to go up here, guys, with this, just so that you can follow it a little bit better. So I'm going to rewrite this top reaction exactly how it is. 6 electrons plus 14 H pluses plus Cr2O7 reacting to produce 2 Cr3 pluses plus 7 H2Os. Then for this reaction, I need to get 6 electrons. I have to multiply this whole thing by 3 to make sure 3 times 2 will give us 6. But you can't just multiply the electrons, you have to multiply everything. So that's going to give us 3 waters plus 3 nitrites reacting to produce 3 nitrates plus 6 H pluses plus 6 electrons. Now at this point we can sum these together to get the overall reaction. And this is going to be long, but we'll do it. 6 electrons plus 14 H pluses plus Cr2O7, 2 minus, plus 3 waters plus 3 nitrites, going to 2 Cr3 pluses plus 7 waters plus 3 nitrates plus 6 H pluses plus 6 electrons. Now guys, that doesn't really make any sense. Why do we have H pluses on both sides? So what you're going to do is you're going to cancel something that's on the left and on the right. So see these 6 electrons? it doesn't matter. I mean, technically it's kind of like how you get paid by your employer, and then taxes come out. You never see that tax. It's a net change that does not have anything to do with what you see. In terms of H pluses, I have 6 over here, which means I can cancel 6 and end up with 8. 14 minus 6 is 8. Waters, I have 3 waters, so that is going to be 7 minus 3 is 4. And I think that's good. So our overall reaction is going to be 8 H pluses plus Cr2O7, 2 minus, plus 3 nitrites reacts to produce 2 Cr3 pluses plus 4 waters plus 3 nitrates. And this is our balanced equation, which I just think is fun. It is long, it is kind of scary. Play around with it, do the practice, try it. And if nothing else, guys, it's only going to be one problem because it's only mentioned one time. And in fact, if you go to if you go to the learning outcomes, there's nothing about balancing redox equations here. So it really shouldn't be on the exam. It could be in your homework because it is important for dealing with redox later on, but it's probably not going to be on the exam because it's not going to be in your review. Okay, oops. Oh well, whatever. So let's go down to our last one here. So here we've got another redox reaction. We're going to go ahead and split it into our half reactions. The 2 things that contain carbon, the 2 things that contain manganese. So that's going to give us methanoic acid reacting to produce carbon dioxide, and permanganate going to Mn2+. So now to balance our oxygens, or balance our carbons, 1 and 1, manganese 1 and 1, oxygens 2 and 2, 4, so I need 4 over here. Now we're going to balance hydrogens. To do that, we need to add H+. We need 2 of them here, 1, 2. Here we've got 4 times 2 is 8, so 8 H pluses here. I think that's it. So let's go ahead and look at our charges here. 0, 0 plus 2. We want it to be 0, so we're going to add 2 electrons. That's the same color I've already got. 2 minus 2 is 0, so now I have 0 on both sides here. Over here I have plus 2. Over here I have 8 minus 1 is 7. So to get 7 down to 2, I'm going to add 5 electrons. Now, 5 and 2 is not the same. So we are going to rewrite this where I multiply everything up here by 5 and everything down here by 2. That's the only way to get to the lowest common denominator, the same number of electrons. So that is going to give us 5 of these reacting to produce 5 CO2s and 10 H pluses and 10 electrons. Down here we're going to have 10 electrons plus 16 H pluses plus 2 MnO4s with a negative charge. Then we're going to have 10 CO2s. I'm sorry, no. Wrong line. Manganese, 2 times that is 2 Mn2 pluses plus 2 times 4 is 8 H2Os. 5, 16, 2, 2. Good. Okay. So at that point we have 10 electrons on both sides. We can start to count them up. Now in the last slide I actually rewrote all of it, but there's an easier way to do it, and that's by just looking at what's on the same on the left and right. So like we can see that there's 10 electrons. We can just cross those off. We don't have to rewrite it to do that. Now H pluses, there's 10 here, which means we can cancel out the 10 here. 16 minus 10 is left with 6. And I think that's all we can do. So we're going to end up with 5HCOOH plus 6H pluses plus 2 MnO4 negatives going to 5 CO2s plus 2 Mn2 pluses plus 8 waters. And that's our balanced equation. Now same thing here guys, like if you look at your homework, these tend to be much shorter problems than what I just did. It's not meant to be overly scary, it's meant to kind of get you comfortable with manipulating equations, which is going to come around a little bit later. But if this is something that you struggle with, try not to fret about it. It's a minor thing. I can give you more practice. We can do a tutoring session. It's totally fine. And if nothing else, it's only going to be on your homework. It's not going to be on your exam. Okay? So as you deal with redox, really focus on oxidizing, reducing, and your agents here, because that is something that you will continue to see on the exam, in your homework, and even later.